Hi guys, today I'm going to talk about the 5 potential habitable exoplanets that are closer to Earth. The countdown will go from the farthest exoplanet to the closest one. I would really appreciate if you could please subscribe and, most importantly, activate the notifications. Alright, so now let's start. Gliese 67c is an exoplanet that orbits the red dwarf star Gliese 67c, located 22 light years away. The exoplanet has an Earth similarity index of 0.84. This index measures how similar an exoplanet is with respect to Earth, which index is 1. Gliese 67c has an orbital period of 28 days, which means that the exoplanet is probably tidally locked and doesn't rotate, showing always the same face to the star. It also has a minimum mass 3 times higher than Earth, an average radius 50% higher, and an average temperature of 8 degrees less, if the conditions were the same as on the Earth. Gliese 67c is an active flare star, and therefore it sometimes releases flares and suffers from sudden increases in brightness. However, this wouldn't be a problem if the exoplanet had a magnetic field strong enough to prevent its atmosphere from being eroded by the star flares. Moreover, the star has between 2 and 10 billion years. If life started on Gliese 67c at the same or similar chronological time as it started on Earth, then extraterrestrial life would have had enough time to evolve in the exoplanet. Gliese 3323b orbits the red dwarf star Gliese 3323 at 17 light years away. The exoplanet has an Earth similarity index of 0.89, an orbital period of 5.4 days, a minimum mass twice the mass of the Earth, an average radius 30% higher, and an average temperature of 9 degrees more. Gliese 273b orbits the red dwarf star Luyten at 12 light years away. The exoplanet has an Earth similarity index of 0.86, an orbital period of 18.6 days, a minimum mass 2 times higher than Earth, an average radius 40% higher, and an average temperature of 12 degrees more. On October 2017, the organization METI sent to Gliese 273b a radio message with music and a scientific tutorial in the hope of contacting possible extraterrestrial civilizations. Any response from them would arrive to Earth as of 2042. Ross 128b orbits the red dwarf star Ross 128 at 11 light years away. The exoplanet has an Earth similarity index of 0.86, an orbital period of 10 days, a minimum mass 40% higher than Earth, an average radius 20% higher, and an average temperature of 25 degrees more. The star Ross 128 has 9.4 billion years, which is more than twice the age of the Sun. On May 2017, astronomers from the SETI Institute detected unusual radio signals coming from Ross 128. However, these radio signals cannot be considered as potentially extraterrestrial because they did not appear again during follow-up studies. Finally, Proxima b orbits the red dwarf star Proxima Centauri at 4.2 light years away. The exoplanet has an Earth similarity index of 0.85, an orbital period of 11 days, a minimum mass 30% higher than Earth, an average radius 10% higher, and an average temperature of 26 degrees less. Proxima Centauri is an active flare star and it only has 250 million years more than the Sun. On April 2016, the billionaire Yuri Miller and Stephen Hawking announced a project called Starshot to send nanocrafts to Proxima b. These nanocrafts, which are miniature space probes attached to light sails, would be sent in 2036 and arrive in 2056, with another 4 years needed to receive the data. Alright, and that's all for today. Thank you very much for watching. Feel free to leave any comment, suggestion or question below. Please like, subscribe, activate the notifications and share this video if you want. Bye bye.